This is video 7.6. Today we're going to be talking about similar figures. We've talked a little bit about dilation yesterday and how a dilation is when you change the size but not the shape of a figure. So when we have that, when that happens, these are called similar figures. So they're figures that have the same shape but not necessarily the same size. So two triangles that are similar are definitely going to have congruent angles but not necessarily have congruent sides. Their sides aren't congruent, but their sides are proportional to one another. So if they're congruent, they're the exact same size and shape. If they are similar, then they have the same angles, but not necessarily the same sides, then they would be similar. So a similar polygon has corresponding angles are congruent, corresponding sides are equivalent ratios. All right, so we're going to use that to find missing dimensions. You can use it to find certain sizes. If you're wanting to know how tall a tree is, you can look at similar triangles to find out how tall your tree is. You'll do lots of that when you get to geometry, right? So in application, one of the things that we often do is we put pictures into web pages. But you know, if you don't keep the dimensions of the height and width, it can distort the image a little bit. So let's say we have a picture that's 4 inches by 9 inches and we're wanting to put it on a web page and it can only be 2.5 inches tall. How wide should it be so that it looks good and the pictures are similar? When we do this, we're always going to take our scale information and divide it by our original information. So we're always going to do scale divided by original. This is going to give us our scale factor. And when we use that, then now we can make a proportion with our scale factor to find out how wide something should be. So our scale factor is our scale over our original, which is 2.5 divided by 4. So our scale factor is going to be 0.625. We can take that and then multiply it by the original width, which is 9 inches. So we do 9 times 0.625, and we find out that our picture should be 5.625 inches wide. Now, you can also do equivalent ratios to find your missing dimensions, which I think is a slightly easier way to do it. Let's say a company's logo is in the shape of an isosceles triangle. The two sides are 2.4 inches long and one side is 1.8 inches long. On the billboard, the triangle with the logo has the sides that are 8 foot long, so we are enlarging. What will the third side length be on the triangle on the billboard? So when we're doing this, we're going to set up a proportion. So we're going to do our 2.4, which are one of the sides. The sides, those correspond to 8 foot on the billboard. Then our third side is 1.8, and we are looking for this other side. So I'm going to show you that it doesn't matter which one's on top and which one's on bottom of this, as long as these refer to the same picture and these refer to the same picture. We are going to cross multiply, so this would be 2.4x. equals 1.8 times 8 is 14.4. I'm going to divide by 2.4 to get my x alone. X is going to be equal to 6. So let me show you that if our 8 is on top here and our 2.4 is over here, because this is the 8 foot and this is 2.4 inches, as long as my x is on top here and my 1.8 is on bottom here, it doesn't matter because I'm still multiplying 2.4 times x, and then I'm still multiplying 8 times 1.8, which is still 14.4. So we get the same equation that we are solving for our x. So it doesn't matter which one as long as they match. So we're going to use the same idea to identify which of these 3 rectangles are similar. Now, because they are rectangles, we know that their 4 corners are all 90 degrees, and we know that their corresponding angles are congruent, so we can say that they are similar. So all we're going to do, we're going to check and see proportion-wise if which ones work. So let's check A and B first. So I'm going to say A has a 3:2 ratio. Matching wise, corresponding wise, if these are similar, then this should be 4:3 and they should match. So let's do our cross product in C. 3 times 3 is 9, and 2 times 4 is 8. Those don't work, so A and B are not similar. Let's check A and C. So let's do the same thing. We've got a 3 to a 2, which would have to be a 6 to a 4. Cross multiply, we've got a 12 and a 12. Those are equal, so A and C are similar. Just for practice, let's check B and C. So I'm going to try 4/3, which is this side to that side, which is going to be this side to that side. 6 to 4. Cross multiplying, this would give me an 18. That would give me a 16, and those are not equal, so those are not similar. So we would say A and C are similar. So the way we draw that, we say A is similar to C, or in science class we usually refer to this as being a proportional statement. We would say A is proportional to C, which is true. That's what makes them similar, is that they are proportional. Click on the link and complete the homework, and I will see you later.